next speaker is Boyd Wilson with Omnibond, and he's going to be talking about integrating iRODS with Project Eureka and Open On Demand.
Good morning, everyone. Can you hear me okay? Excellent. I have like 5 pounds of flour of talk to fit into a 1 pound time frame, so I'm going to go really fast through the top part, but I wanted all these slides in there so everyone could kind of look and see and know what's going on, kind of the background information. Real quickly, Omnibond is actually a spin-off of Clemson University, so we have academia and research in our background, but we are a for-profit. There's more details of our leadership team, and we do have other software products. We do identity and security management, mostly sold through Micro Focus, now OpenText because OpenText acquired them. But we also have launched OmniPasskey passwordless MFA plugin for Shibboleth 4, which is something that's kind of interesting and very useful, more community oriented than the other identity stuff. We do computer vision and AI for the transportation industry, and then we do cloud HPC storage orchestration. We are the maintainers of OrangeFS, both the open source project and the upstream kernel Linux, the Linux kernel modules. And then we're going to get into the Project Eureka. And there's a little bit more about traffic vision. Feel free to look at that. We have done some scaling exercises in the cloud. This 1.1 million vCPUs in AWS. We also, Google wanted to do a little better, so we helped them do 2.1 million vCPUs. This was in conjunction with Dr. Apon at Clemson University. And this is kind of the overview slide of what our current product, Cloudy Cluster, does, which really lets you spin up high-performance computing, put hints in jobs, and provides a UI to kind of do all of that easily in Google and AWS. But they're kind of isolated in Google, isolated in AWS. And it doesn't include iRODS, doesn't really even think about data management other than providing data at a mount point like most HPC systems. There's a GCP version. We did some work with the Open On Demand community to integrate Open On Demand as part of Cloudy Cluster. There's a nice story behind that if you want to hear it, I'll tell you later. But we've continued to work with the Open On Demand community through that. Here's some cryo-EM stuff. Here's some SDPB solver. Walter Landry, we did that with. He actually works for SpaceX now. We did some work with Tapis, which is very interesting, spinning up dynamic HPC. This is all with the Cloudy Cluster product. Goes over the meta-scheduler approach. We have a meta-scheduler that runs in front of Torque or Slurm and dynamically spins things up, tears them down. So that's kind of, that's applicable in the future. Okay, Project Eureka. Project Eureka is the next evolution of Cloudy Cluster. It's a ground-up rewrite, greenfield development project where we're actually looking at interactive computation. Open On Demand kind of introduced this concept, and others have done it before, but it's really got a lot of adoption where you can launch applications from a GUI, interact with your data that's on your HPC system, and do some very interesting things. And we also worry about compute, and we also are worried about storage. We really want to provide application launchers. We'll have a demo in a little bit. And API applets is kind of a new concept we've come up with, because all these APIs out there on the internet. We'll have a demo of that. But the UI, there's a lot of requests to make it project focused, not user focused, project focused. Here's a project, here's people working on the project, here's the data for the project. Let's launch compute or interactive from that project perspective. On the compute side, my allergies are like way off the rails today, so apologies, and all week for my coughing. The compute anywhere concept, Cloudy Cluster did, okay, AWS, okay, here's Google Cloud, you can go do that. With Project Eureka, we want you to say, okay, I want to compute on-prem, I want to compute in AWS, maybe 3 different accounts, I want to do some Google stuff over here because they have TPUs, I want to do some OpenAI stuff because they have cool stuff. Really, data should drive your compute, or compute should drive your data if your data is too big to move things around. So really, how do you build a framework for this and make it easy for data scientists, traditional HPC practitioners that like to see the guts, or even new people that are just moving from the desktop because their data is getting too big to something else. And then storage, we really wanted to integrate diverse storage resources at the project level. So project leads could go in and say, hey, I want to add data. I want to do this. Concept of collaboration first. Think about collaborate and build around that. And then again, project level and data lifecycle management are going on. So here's the technology that we've really focused on. CloudJump UI, you also see it referenced as the OOD UI. I'll show it in the layer cake diagram. It works kind of out of Open OnDemand as a passenger app. And so we really leverage that. The Omni scheduler is kind of the next evolution of our meta scheduler from Cloudy Cluster that allows you to really do things. And we're going to introduce some interesting concepts with that. One of the interesting things that we've done is constellation. When we first started using Cloudy Cluster, there really wasn't an API. There really wasn't anything that allowed you to do cross-cloud. Terraform has kind of evolved to the industry standard cross-platform, cross-cloud way, and it's even maintained by the cloud vendors. Most of the cloud vendors maintain their own Terraform stack. So we leverage that, and we actually build a constellation layer that automates that at kind of more abstract constructs like parallel file system, instance groups, those types of things. So then you can move it, and then it automatically generates the Terraform under the covers and maintains it, spins it up, tears it down. And then iRODS, metadata-driven data management and movement, and really designed for diverse storage. And as things evolve and we get into lifecycle management, obviously the metadata will have more and more impact. We started this project, really started development in January, right? Is that about right? We started from an inside out philosophy, and this is because the project we're working on with a Ivy League business school. And they really wanted the Open OnDemand UI, wanted the project-based interface, very design forward thinking. And then we'll get to project leads UI, then we'll get to admin UI. Kind of let's work on that interactive user experience, which impacts the researcher real time first, to build the stuff around. And classically, when we develop things, okay, let's build the admin interface so we can do stuff, and then we'll finally get to the user interface because we have to set things up. So we actually did an inside out methodology here. One of the things I like to, how many are familiar with Open OnDemand? Okay, a handful. What's interesting with Open OnDemand is they really struck a chord with, there's a lot of people that really want to use high performance computing resources and data intensive computing resources with a GUI. And you can see there's a large number of people using it. And hey, we need a slide of using this like iRODS when I'm out showing other people, not just, I do the consortium now, but it'd be nice to have a user's version like this because it has some impact. And so anyway, so that's why we're using Open OnDemand. We've been working with them for several years. And obviously we're using iRODS. Y'all know why we're using iRODS because you're all here. The passenger app that I mentioned and Open OnDemand apps are kind of parallel. There's Open OnDemand. This is kind of coming from the user interface down. Then we have the Omni scheduler, which is that meta scheduler layer that'll handle everything from long-running processes to HPC jobs. And Constellation allows you to kind of build that layer of, this is an HPC compute group, this is object storage, this is parallel storage. We actually even spin up the iRODS server as kind of like these templates that go through Constellation, automatically generates a Terraform, and then we can target multiple clouds very easily. And Terraform is very nice because each one's different, but if you go look at the APIs, Terraform is much more similar than, just hitting the APIs, all these crazy cloud providers and the authentic, all the other mechanisms. So right now, what you'll see in the demo is AWS, but the plans to continue porting to GCP, Azure, Docker for local development, and then even KVM for on-prem HPC, because there are a lot of HPC people that came to us saying, hey, we want this cloudy cluster stuff, we want it on our cluster. And I say, well, here, run OpenStack. We can you know, we can build an interface for that and say, we don't have 3 people to run OpenStack. We want it on our HPC cluster. So it's been interesting. So our thoughts are, and we still have to do some R&D there, but you know, this interface to KVM, leveraging the networking that's there, the high-speed disk, we can do some stuff like that. And then we have iRODS over here meshed up with the compute. And one of the goals of this project is to empower the job script. And we did that a little bit before in Clouded Cluster by allowing you to select, I want spot instances, I want this instance type. You can control it all from the job script. And what if you had data staging? Hey, I want to data stage from here to here in my job script. I want to stage results out. That should all be, have that ability in that job script. And then iRODS interface to Globus. So if you have to do some wide area stuff with other sites you're collaborating with, it gives you that clean path to pull data in and out, keep it in the catalog, and then you have the apps. So when we are designing and started building the Omni scheduler, we really wanted it cross cloud. So we're going to introduce some strange concepts for schedulers like routing. I want to route a job somewhere. I want to do some things like that. So that's coming. We're getting the core done, and that's coming. We want dynamic scratch. If you ever do scratch in the cloud and you want to get enough performance, you have to throw all this storage at it to get the performance you want. And it gets really expensive if you leave it running. And if people start leaving stuff sitting there, it's horrible. So we're going to introduce the concept of dynamic scratch. Spin up scratch, schlep the data in, run the job, take the results out, blow it all away. And then we want to go to beyond HPC, data science apps, HPC adjacent, publishing, websites, those types of things. How do you enable that? You have those templates, you can do stuff and go through. Kubernetes, Spark, whatever else, Quantum. I keep saying we need to make sure we can route jobs to Quantum, and then we'll make sure that we'll be able to do stuff. So you can route some things up to, you know, the Quantum in the cloud. And then schedule, even just scheduling data movements. And in addition to job-based directives, and you know, we really want the data management capability so people can set up storage endpoints that automatically take care of, I want to replicate this here to here. I want to have an ingest landing point here. And we want to make that easy. And there's a lot of work to make that easy. Tier, publish, those other things. Running short on time. Here's kind of the deployment architecture in the cloud. Feel free to look at it. And that's kind of a single site. And what's interesting is you go to a second site, and you're going to have a login node. You're going to have, you know, the Omni scheduler. What's interesting is when you go do anything in the cloud or on-prem, something has to have permissions to do things. And so we've kind of come up with this concept of an entry point. So here's an entry point into this account or this project. And really it starts with an Omni scheduler. And so you set up the IAM or permissions or access or who it logs in as, depending where it is. And then once you have that there, it has the established permissions and the secure communications and all those other things that it can then do things in that region. So that, or region or account or whatever, that target. And then it can spin up, tear down, whatever, and also make sure that the firewalls and everything are set up along the way. So, you know, that's where we're headed. So let's go to a demo. Demo will require glasses. So this is, so just so you know, this is what the Open OnDemand interface looks like. This is actually a passenger app. Already launched it, don't worry about it. But you can go directly to this passenger app and never see Open OnDemand. So this is a project I created. And we'll go in and say, okay, here's a project. And here are the interactive applications that are available for this project with these collaborators. So let's say I already have a Jupyter 4 instance running, but let's go ahead and launch an RStudio, launch a Linux desktop. And while we're at it, let's do some VS Code. So we'll let those run. Launch in a minute. You can see that when you want to connect, Open OnDemand kind of started this philosophy. And and what's interesting is I didn't neglected to mention earlier is Open on Demand runs as the user. Actually, when you log in, it hands off to a per user Nginx process, and then everything you do is running as that user. And so everything we've tried to do is kind of stay in that paradigm. Where it shifts out of that paradigm is at the scheduler interface. We've added a couple of other interfaces where you go out of that, but you log into that entity, including iRODS, as that user. And we've set it up so you can have a JWT automatically generates and you're logging in as that user. So we're trying to keep that metaphor throughout, because a lot of people who worry about security like that methodology. Anyway, so Open on Demand, launch a new tab, and there's Jupyter. Now, what's interesting is we go into here, and here's all the different things, but we have this interesting symlink called projects, and here's all the projects, and this is all going through NFS rods. And so here's the iRODS demo project that we were looking at. And right here is kind of the mount point, for lack of a better term, for all the collections. So as we bring in like an S3 bucket, or you bring in other things, they will show up under here and in the mount. If we go one further underneath, then you'll see there's the data that I have stored in the vault, kind of the default for that project. Okay, so that's kind of interesting. So let's go back to this and go, oh, hey, I'd like a web GUI to do this. So this is a web UI accessing the REST APIs to fully provide, you know, it's evolving, but, you know, here I want to upload, and this is not my laptop, so I'm actually not going to upload something because I'd feel really bad. But here's some data I put in here earlier. FY22 budget, I threw that in there. You can, you know, decide if you want to drag and drop something. Let's say I want to move this up here, and notice I've just moved that. So right now, move, and we'll be adding copy paste. We'll be adding zip download, those other things. So it's really kind of Google Drive inspired UI for managing iRODS interface. And when I mentioned project storage before, is that kind of mount point or landing point. As you add different resources, or they'll show up as new collections. So real quickly, before you throw me off the stage with the big hook, one of the interesting things we did is that document I put out there, we actually built an applet that talks to OpenAI. And so we can actually, so I built this chat, so this is not talking directly to OpenAI. This is using OpenAI to talk to that FY22 budget, which is just US's annual budget document for last year, because it was about the right size. And so, you know, what's in the table of contents, blah, 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 blah. So just to kind of show, and you actually get to show in the mount point where it's reading the data from that file and say, you know, tell me more about government. Oh, I already asked that question. Anyway, it's going to let's see if it gives me the same answer. And this is actually every time reading that document in, so it takes a little while to pull it in, and it's chunking it into the model. But this is kind of that concept of whatever comes down the road, we want to be able to integrate that into this so you can use it with your data from this data science platform. Like I said, it's a big document. Anyway, while it's answering, we can go on to questions. So that's the quick overview of what we're doing. Any questions, or I'm done?
Questions?
Oh, there it is. There's the answer. Scroll.
Any questions? So I guess, oh, we got one.
So is this an addition to Open on Demand, or is this like a custom Open on Demand install?
So one of the things, Open on Demand doesn't have a project view, and we work closely with Jeff Oshram and Alan Chalker and the team at, you know, OSC to look at that. And so we actually have developed a Python, you know, JavaScript that runs in parallel on the same node updates the same thing. So everything, so if you go look in, oh, I can show you later, but if you go in and look at Open On Demand, you'll see those are interactive jobs. So it's tightly integrated, but it's a little bit of a separate stack going out, handling projects. And we actually have some technology we collaborated with developing over the years called AFW that can do rules-based authorization for the project stores, still keeping that methodology. So it's kind of sitting right next to, but it is a passenger app.
Thank you. Yeah, I'll follow up with you.
Any other questions? So this is still in active development. Is this released?
This is like alpha. You're looking at alpha.
Okay, okay. So this is not available yet.
There's still a lot of stuff to be done.
Is there a particular target date for when you expect to have something available for people to try out, or?
Probably and it depends on how much of it you want to try out. Because this is a long-term project.
Okay.
But in the fall, we're thinking of having our first deployments for people who are really interested in the data science aspect, the interactive apps. There'll be some HPC capabilities. Those will evolve over time. But yeah, so it's a rapid thing we're pushing towards.
All right. Excellent. All right. Thanks.